Okie dokie, so today I'm talking about the second derivative test and mainly concavity, because the second derivative test tells us concavity, but first I want to talk about what concavity is. So in regards to this direction, first I want to talk about what is concave and convex. So this thing would be concave, and right here this would technically be convex. And usually we talk about it in mirrors, so like if you shot a light here, then it'd bounce off kind of in that direction or in that direction. So, and then if you shot it at here, the light would bounce in that direction, so kind of caving. This goes in towards the middle, and things come in at it and in towards the middle, and this comes into it and out. And so like in a hospital, if you ever seen like the bubble mirrors, those would be a convex object, or like the cornea on your eye, that would be a convex object. And concave would be the opposite, so kind of like this little cap here, how it's concave, there's a cavity in there that it goes in. And so when we talk about concavity in a graph, we're going to talk about whether it's concave or not. Not really, we don't talk about convexness, just concave, because convex we can see if you look at it from this side, it would just be concave this way rather than concave this way. So we're going to have two types of concavity, concave up and concave down. Concave down. And so some examples of that. Concave up would look like this. Think of it like a bowl. And then concave down would be like that. And so kind of if I shaded where that would be like a bowl, and this would be like a kind of like a hill. And in math, we have ways to describe this. A little diagram. And the diagram looks like this. It's a tad complicated, but it covers the point. Boop, boop. So we have these types. So these two would be concave up, these two would be concave down. And then I'll draw a graph, and we'll talk about concavity and what an inflection point is, and all that. So in this one, f prime of 0, or f prime would be greater than 0, so a positive slope. So we can see that the function itself is increasing, an upward slope, but the second derivative is less than 0, so negative, or concave down. So this would be increasing, concave down. In this one, we're going to have an f prime that is less than 0, so it's negative, and then a f double prime that is also less than 0, so it's concave down. And so that would be decreasing, concave down, or concave down. And then these two is the function is decreasing from left to right, so f prime would be less than 0 or negative, and then but f double prime would be greater than 0 because it's concave up, so positive. So decreasing and concave up. And then this one, if you can guess, the function is increasing from left to right, so f prime is greater than 0, so that's positive. And its concavity is also up, so that f double prime is greater than 0 as well, positive. So this would be increasing and concave up. And so if I draw a little curve over here, like this, and say I have a curve like that, so somewhere here, and I draw the graph like that, somewhere here it's concave down, and then it turns up, and then like right here it'll turn to concave down, and then there's an inflection point, concave up, and here it's concave down. And so the points, so an inflection point is just a point where concavity changes. It's where concavity changes. And those are going to be critical numbers on for f double prime. And that's concavity in a nutshell. So I hope that was helpful.